Today we're going to talk about tessellations. So obviously the first question you should probably be thinking about is, well, what is a tessellation, right? So a tessellation is created when a shape is repeated over and over again on a plane without creating any gaps or overlaps. So a tessellation is created when a shape is repeated on a plane without any gaps or overlaps. So if I were to take a shape and I were to repeat that same shape all over on a specific plane, if it didn't have any gaps or overlaps, it would be considered a tessellation. So if you look at this picture here, notice I have a triangle. They're all filing next to each other. I don't have any gaps anywhere, or none of my shapes are overlapping. So a perfect example of a tessellation would be like a bathroom floor. So if you have a tile floor anywhere in your house, specifically usually they're in the bathroom, all of the tile floors, they're perfectly laid next to each other. There's no gaps where you can see, just the structure of the house, the floor, and none of the tiles are overlapping. That's what a tessellation is. There are famous art tessellations out there. There are famous artists that have created beautiful paintings and drawings and pictures of tessellations because they're a really cool, almost like an optical illusion type design. So if we go ahead and we keep going, I can actually probably show you what one of those tessellations are. Let's go ahead and look. So if I go to the browser and I just go to Google, let's see if it'll let me just go to google.com. And I'm going to type in Escher. Escher is one of the famous artists who creates these tessellations. And it should be searching. If you look at any of these pictures, these are all examples of tessellations. These are all shapes repeated over and over again that have no gaps and no overlaps. Look how amazing that one is. They're all used by similar shapes and not regular polygons, but different types of shapes to create these tessellations. So these are just some examples of what a tessellation in the art world would look like. So if we go ahead and we keep going, let's now talk about what a regular tessellation is. So in order for something to be a regular tessellation, that just means it's a tessellation made up of regular polygons. So a regular tessellation is a tessellation made up of regular polygons. So this example up here is an example of a regular tessellation because these are all triangles. They're all equilateral triangles which create the tessellation. All of those Escher designs that I showed you, those are obviously not regular tessellations because they don't use all regular polygons to create their structures and their art. So the big question is I want to know which regular polygon tessellates in a plane. So like if I were to take, triangles here, and I were to stack triangle, 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 are there going to be any gaps or overlaps? And the answer is no, because based on that picture, it doesn't look like it will be, so there won't be. But what about if I had a pentagon? If I had a pentagon and I laid another pentagon next to it and another pentagon next to it, is it going to be able to lie flat with no overlaps and no gaps? So we have a way of how we figure out how to do that. So I'm actually going to go ahead and just write it up here, only because I'm going to run out of space otherwise. So just find some space, preferably at the top, of how to do this, because this is the most important part. So the most important part is how to determine if a regular polygon tessellates. So to determine on how, if a regular polygon tessellates, all I have to show is I just have to show the interior, let's say show that one interior angle is a factor of 360. In order for something to tessellate and for there to be no gaps and overlaps, I bring the all the vertices together, they better make a circle. All circles add up to equal 360 degrees, which means this plus this plus this plus this plus this plus this have to make 360. So, and notice these are all interior angles. So in order for a regular polygon to tessellate, my one interior angle needs to be a factor. It needs to be divisible by 360 degrees. So if we come down here and we look at these following polygons, I want to know if the following polygons could tessellate in a plane. So how I got to do that is I first have to figure out what my interior angle is. How do I find what all of my angles add up to equals? Anybody remember that formula? Hopefully you're telling me it's n minus 2 times 180. So obviously in a triangle, you know all your angles add up to equal 180. So how do I find what one angle equals? We'll have to divide by 3. 180 divided by 3 is 60. So now that I have this interior angle, I need to show that that interior angle is a factor of 360. So I'm just going to do 360 divided by 60. 360 divided by 60, well, that's what? 6. So since it goes into it evenly, I would say yes, equilateral triangles tessellate, or yes, it tessellates. Let's go over and let's look at a square. In a square, all angles in a square add up to equal how much? Well, they add up to equal 360. Well, how do I find what one interior angle is? I divide by 4, which is 90. So now I want to take that interior angle and I want to see, okay, fine, is 90 a factor of 360? 360 divided by 90, well, that's 4. So yes, it tessellates. Let's now go ahead and find a pentagon. How do I find what all 5 angles add up to equal in a pentagon? Well, I have to do n minus 2 times 180. So that's 3 times 180. So that's 540. So then I have to divide to find one interior angle. I have to divide that by 5. So that's equal to 108, right? So now I need to ask myself, okay, 108. I need to assess and I need to see is 360 divisible by 108. Well, 360 divided by 360 divided by 108 is 3.3 repeating. That is not divisible because it doesn't go into it evenly. So I would say no, it does not tessellate. So I want you to go ahead and pause this video, and I want you to try the next 2 on your own, and then when you finish, unpause, and I'll just go over the answers. So if I look at this one, I have 1, 2, 3, 4, 5, 6 sides, so I would do n minus 2 times 180. So 4 times 180 is 720, divided by 6 is 120. This is my interior angle. So now I need to ask myself, okay, is 120 go into 360? So 360 divided by 120 is 3. So yes, it does. If I look at the last one, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So 8 times 180 is 1440. Divide that by 10, I get 144. I now need to ask myself, okay, is 360 divisible by 144? Well, 360 divided by 144 is 2.5. So no, it does not tessellate. So that's all you really need to know about tessellations. So now, if we go down and we need to look at these problems, this is determine whether the following patterns could tessellate in a plane. Explain your reasoning. So if I look at this first picture, how do I know it's a tessellation? Well, because there's no gaps and there's no overlaps. So I would say yes, because there are no gaps and overlaps. If I look at this next one, does that one look like a tessellation? No, because there are gaps. If you look right there, there's a gap right there, which I'm not going to be able to fill with a regular polygon. If I look at the last one, yes, because the same reason, no gaps or overlaps. If we go ahead and we look at this last problem, this is a perfect problem. I see these problems a lot. A tiled floor consists of the following tessellating pattern of two regular polygons. A portion of the tiled floor is shown below. What two regular polygons are used in the tessellating pattern? So I can only use two shapes. So I want you to pause this video and I want you to see if you can figure out what two shapes are being used in this tiled floor. Obviously, when you're done, you're lost, go ahead and unpause the video and I'll explain. Hopefully you're looking at this and you automatically know that the first shape is a square because that's what's in the center. So my first shape is a square. To find my second shape, if that's a square, I know that's 90, right? And then so my second shape is both whatever this is and whatever this is. So I know those angles are the same, correct? So if I give them an x and I give that an x, what do I know about all three of these angles? Well, all three of those angles have to add up to equal 360. So x plus 90 equals 360. So 2x equals 270. So x equals 135. So x is 135. So if my interior angle is 135 degrees, how do I find my number of sides? Well, remember when I have my interior angle, I have to find my exterior angle by doing 180 minus 135, which is 45 degrees. This is my exterior angle, because remember, an interior angle and an exterior angle make a linear pair. And now that I have my exterior angle, I can just do 360 divided by 45. Because remember, all exterior angles add up to equal 360. So 360 divided by 45 is 8. So 8 sides. My last polygon is an octagon. So these are famous test questions. So make sure if you have any questions, you come and you see me.